Hi, it's time for another math easy solution to discuss further into laws of exponents and now look at part 3 of the series and solve this equation, this law right here, which is e to the x, and then in bracket the power of r equals basically e to the rx. You can just interchange, it doesn't matter where it is. And basically, to recap on all three bits, if x and y are real numbers and r is rational, meaning you can write it as integers. For example, 1 divided by 3, that's a rational number. Those are both integers. 2, etc. So if you could divide by integers, or 1, except you can't divide by 0, then that's rational there. And then basically you have e to the x plus y equals e to the x times y, e to the y, but if it's a minus, you just divide. I did these two videos in I did 2 videos on this in my last videos on proofs of these, so make sure to watch those, and today I'll go over this one right here. Yeah, now the proof of this one, it's pretty straightforward. I show the proof, it's similar to my last videos where I start off by writing ln of now this part right here, e to the rx, and basically use log properties and their laws to basically break this down. So this one we could write this as, breaking it down here, we'll have a rx times by ln e right here. So this is, yeah, you can just write it like this, and you can see proof of this law in a video link below on how to bring this down. Basically now what we could do here is basically write, just put a bracket here to separate this from the r, just so now we deal with this separately. And now we use the same law which I had to bring it down now to bring this up. So now we could write this as r times ln, now bring this up to e to the x. So we just did that same exponent law here separately. And now what we could do is basically bring this r up around this, so we could even put a bracket here. So basically just dealing with brackets in the order of the exponents, and it doesn't matter. I'll show, as I will show right here. So now when we put this r, we could take it back over there, so we get ln of and now e to the x, and now bracket r right here. So this means basically ln of e to the rx has to equal to ln ex bracket r, and like I showed in my earlier video, yeah, basically ln is a one-to-one function right here, and this just means that each y value has exactly one x value. And once again, similar to the other proofs, if you draw ln x like this is what it means, basically the one-to-one function. If this is ln of x for any given y value right here, it has only one x value, so it's not like a trigonomic function where it goes up and down and you could have multiple x values for any given y. So if this is true, so we could write is, because we know that basically ln of e to the rx is equal to ln of e to the x, and now in brackets r. So because this is true, and this could be considered as the y value, so then this just means that it has only one x value. So if it's only one x value, this just means that this inner function, or these inner x values, has to be the exact same. So we get e to the rx equals 2e to the x r right here. Yeah, and that's basically our proof for the third law. And also, in fact, this also holds true if r is any real number. It doesn't have to be a rational number, and we'll show this in later videos. Basically, we needed this rational number for this exponent law here to bring it down right here. Yeah, because in my earlier video I showed the proof for this law right here would bring the r down, or the rx, and this was for rational number, for where r was rational. You can see the proof of that in the video link below. Anyways, that's all for today. If you learn from this video, and like always, you can download these exact notes in the link below, or even just type these in the URL and get the PDF and Word notes. Anyways, thanks for watching, and that's all for today, and stay tuned for another math easy solution.